So what is now being done? So we realize that this is a problem with the ozone layer thinning. So what is being done about it? So what is being done is in 1987, there was a meeting in Montreal and established what was called the Montreal Protocol. And in the Montreal Protocol, different countries agreed to phase out these CFCs. So they agreed to phase out CFC production by 1996 and to phase to HCFC production by 2030. The phase out, again, they go from CFC. So CFC is very, very stable. They don't break down. And so they last a really long time. So when they get into the air, they get up into the stratosphere. Once you start introducing hydrogen, so rather than it being like CCl2, F2, once I stick a hydrogen on there, so it's like HCl F2 or something like that, it tends to break down a little bit faster. So less of it gets up to the atmosphere or up to the stratosphere, more of it breaks down. Now this is going to be my solution. Eventually to phase to these HFCs. So it would be like H2C F2, something like that, no chlorine on it. Chlorine tends to make it a little more persistent. And again, that chlorine-free radical issue. And so by phasing to HFCs, they're going to decompose in the troposphere. Actually, I'll go to the next slide and show you that. So they're going to decompose in the troposphere. Okay. And so they're going to break down in this bottom layer before they reach the stratosphere. And that's going to help with that. So this is the solution that was agreed to. So it was a law, it was a treaty. This is a global problem. So no one's king of the world. So you have to propose a treaty. So you propose the treaty, and the treaty was the Montreal Protocol. Most countries signed it and agreed to kind of phasing it out. Developing countries, it got longer to phase out CFCs, et cetera. So this is what the solution was. The challenges associated with mitigation is, again, getting everyone in the world to agree. But I would say even more so is now, as we, how is global warming related to, or climate change related to ozone layer depletion? They're not. They are totally separate issues. This is about the stratosphere and ultraviolet radiation. It has nothing to do with heating of the earth. They are not related. A big misconception is that they're related. There is a little bits of crossover. We will see that that CFCs are a greenhouse gas. And in fact, some of the challenges with addressing ozone depletion have actually contributed to global climate change, because essentially CFCs, so again, HFCs replace CFCs. However, they have a huge, in some cases, higher global warming potential. So we'll be looking at different greenhouse gases. You're probably familiar with that CO2 is a very common greenhouse gas that we hear a lot about, comes from combustion of fossil fuels and other things like that. So we're very focused on CO2. The global warming potential of CO2 is 1. In fact, you can kind of see that in this table down here. Okay, its warming potential is 1. CFC12 is 10,300. So one CFC12 molecule has more warming potential, or is equivalent warming potential of 10,300 CO2 molecules. So this is where reducing CFCs is really great. It's going to help with global climate change. However, we're replacing CFCs with HFCs, and you'll notice HFCs, like in this case, HFC 23 actually is believed to have a higher warming potential than CFCs. So we're solving one problem, thinning of the ozone layer of stratospheric ozone, and we're maybe making another problem, global climate change, worse. So that's where so often it's very hard to come up with solutions to things. And again, it's not crystal clear. So this is a table with a little bit more data. IPCC, we'll talk about that with climate change, but basically that's the International Panel on Climate Change. And they go through and they study all sorts of research and bring it together on climate change. And you'll notice the numbers change as they do more research. They say CFC, the warming potential is bigger or less or things like that. So I just share this with you. It's not like super clear, like this is that. But one of the big challenges is the solution to stratospheric ozone thinning is these HFCs. And these HFCs still have a very high global warming potential and then contribute to ozone layer. They it solves ozone layer, but can contribute to global climate change. So that's one of the big problems with it. Some people say we need to shift to refrigerants that don't have a global warming potential, or we need to shift away completely from like air conditioning, and use fans more, and better insulation. So things like that. So again, you can get a lot of interesting solutions coming out of that. That's basically stratospheric ozone thinning in 3 not too short videos. I hope that was helpful and clear. Reach out if you have questions.